What if you could type on any computer in the room without ever touching it? No, it's not Bluetooth. It's something far more powerful, far more stealthy, and you can build it yourself for under $10. This is the Atom Ducky. It turns this tiny $10 microchip into a ghost in the machine. A wireless keyboard injection tool that makes the classic rubber ducky look like a child's toy. Today, you're not just going to learn how to build this. You're going to learn how to think with it. Stick with me to the end, because I'm going to show you the critical difference between how a total noob hacker uses this versus how an FBI most wanted hacker, codenamed Crazy Panda, would use the exact same tool to become a ghost. The difference will shock you. Let's get started. Before we go any further, a critical disclaimer. This video is purely for educational purposes and ethical hacking demonstrations. Using such tools without explicit permission on systems you don't own or have authorization to test is illegal and unethical. We're learning how these tools work so we can better understand and defend against them. Always get consent. Depiction is not endorsement. First, let's understand the inspiration, the rubber ducky. Imagine a regular USB stick, but when you plug it in, your computer thinks it's a keyboard. And not just any keyboard, one that types at lightning speed. These devices are often called HID, Human Interface Device, attack tools. They can inject pre-programmed keystrokes known as a payload or ducky script to do anything from opening Notepad and typing Hello World to downloading malware or creating new user accounts, all in a matter of seconds. It's incredibly powerful, but traditionally, you need physical access and the script is loaded beforehand. Now, what if we made that ducky wireless? That's where Atom Ducky comes in, and our star for today, the Raspberry Pi Pico W. The Pico W is a tiny, affordable microcontroller with built-in Wi-Fi. The Atom Ducky project leverages this to create a Wi-Fi-controlled rubber ducky. This means instead of preloading a script, you can connect to its Wi-Fi network and control what it types in real time through a web interface. Why is this cool? Flexibility. You can adapt your attack on the fly, try different payloads, and experiment without constantly plugging and unplugging the device. All right, let's get building. Here's what you'll need for your own Atom Ducky Pico W. Raspberry Pi Pico W, the brain of our operation. Make sure it's the W version for Wi-Fi. Micro USB cable for flashing the firmware and power. Optional OTG adapter if you want to connect it to a smartphone or a system without a standard USB port. That's really it. Super simple, super cheap.
Oh my God!
Before we start flashing, we need 3 main files downloaded to our system. All links are in the description below. The Atom Ducky project. We need the project files from the official GitHub repository. The Pico W reset file, a flash _new UF2 file that we'll use to completely reset the Pico W's flash memory. CircuitPython firmware, the specific .uf2 file for the Raspberry Pi Pico W, which provides the environment for the Atom Ducky code to run. Step 1. Flashing CircuitPython. This is the foundation of our project. Hold down the bootsel button on your Pico W, and while holding it, plug the USB cable into your computer. Then, release the button. A new drive named RPIRP2 will appear. Now drag and drop the flash _new UF2 file onto the RPIRP2 drive. The Pico will automatically reset, and the drive will disappear for a moment. The drive will reappear. Now drag and drop the CircuitPython.uf2 file onto the drive. It will install, and the Pico will reboot again. When the drive reappears, it will be named CIRCUITPY, and you're ready for the next step. Step 2. Copying the Atom Ducky code. Once you've downloaded and extracted the Atom Ducky project, you'll see there are 2 main versions, one with Bluetooth support and one without Bluetooth. Since we're using the Pico W, which is Wi-Fi capable, we'll focus on the files inside the Atom Ducky, no Bluetooth folder for simplicity, but know that the Bluetooth version can also work. Open the Atom Ducky, no Bluetooth directory. We can see all the project files here, but they pose a crucial challenge. The entire project is about 700 kilobytes, yet our Pico W's flash drive only has about 490 kilobytes of usable space. This means we must optimize the files first to make them fit. We need to target the largest image files. Navigate to the static folder. Here we see the main file names, like logo.svg and favicon.iko. These are large culprits. Delete or replace these images with optimized, smaller versions. I'll be using my pre-optimized images. You can download them from the link in the description. Now come back to the main Atom Ducky folder and navigate to the Atoms folder, then into the website_atoms folder. Here, you'll find the ducky.svg image, which is around 200 kilobytes. We need to replace this image with our custom, smaller version. I'm pasting my custom Ducky image, but its extension is .png, not .svg. Because we changed the file extension, we must update the HTML file so the code runs smoothly without breaking. Come back to the main Atom Ducky folder and open the index. HTML file with a text editor like Notepad++. Use Ctrl+F to find the original ducky.svg image name. We'll change the reference from ducky.svg to ducky.png and save the file. Once you have this modified, smaller version, around 100 kilobytes or less, copy the entire optimized contents of the Atom Ducky folder into your new CircuitPy drive. Step 3. Configuring the code with the Atom Ducky files now on the Pico W, we need to customize the code to run smoothly and connect to the internet. We'll use a text editor like Notepad++ to view and edit the files directly on the CircuitPy drive. The Raspberry Pi Pico W doesn't have a built-in NeoPixel LED strip. To prevent errors that stop the Wi-Fi server from starting, we need to assign fake GPIO pins. Navigate into the Atom folder on the Pico W. Open the buttons.py file using your text editor. Change the NeoPixel reference from board.neopixel to board, GP12. Change the button reference from board.btn to board, GP13. Save the buttons.py file. Next, we need to tell the Atom Ducky where to connect. Open the config.py file. We're connecting the Pico W to your network, ideally your mobile hotspot so you can control it from your phone. For simplicity, I will enter my home Wi-Fi SSID, network name, password, and the static IP address you want the Pico W to use. This setup will allow both my computer and my phone to be on the same network as the Pico W for remote control. And that completes the entire setup process. For the changes to take effect and for the code to run smoothly, we need to unplug the Pico W from the system and plug it back in. The device will restart and connect to your specified Wi-Fi network. Once the code runs successfully, your Pico W will connect to your hotspot and get the assigned IP address. Open your browser and navigate to the IP address you have assigned by the hotspot, or in my case, my Wi-Fi access point. So this is the Atom Ducky Web UI, the control center for this powerful Atom Ducky tool. As you can see, our previously modified and custom optimized Ducky image is displayed right here on the web page. Now pay close attention. On the right side, we find the crucial HID menu. This is where the real control happens. Right here, we see the Modify Payload button. We use this exact button to directly modify and save our Atom Ducky script. To create an Atom Ducky script, the developer on the Atom Ducky GitHub page provides all the necessary steps and the complete payload syntax. This documentation is what helps us create our powerful payload. Using this official payload syntax, I have created a basic Atom Ducky script payload. Now we just click the Soul Payload button to save our script. After that, you can see the Inject Payload button. Upon clicking this button, it will instantaneously launch our saved payload. As you can see, it has opened the Windows search menu, typed Brave, and the Brave browser opens instantaneously, taking us directly to our YouTube channel's main page. But wait, there's more. The power doesn't stop with pre-scripted payloads. Take a look just below the payload controls. You can also see the Live Keyboard feature. This is where we gain direct, real-time interactive control. Think of it as having the target machine's keyboard right in your hands, remotely. With this live keyboard, you can type anything you want on the target machine on the fly. As you can see, I am now typing on the target machine with my attacker phone, and every character appears instantly on the remote screen. This allows for dynamic interaction, spontaneous commands, and complete control, turning a simple payload injection into a full remote administration session. Now, let's explore some of the other game-changing features that make the Atom Ducky toolkit so versatile. First, we have the single payload feature. This is perfect for quick tests or one-off commands. It lets you compose and send a single, temporary payload directly without overwriting or affecting your main saved payload.txt file. It's a sandbox for your ideas. Next up is the Templates Manager. This is your arsenal of pre-configured attacks. Here, you can easily add, modify, and instantly run a library of your favorite payloads. Whether it's a reverse shell, a credential harvester, or a system info grabber, you can save it as a template and deploy it in seconds, making your workflow incredibly efficient. Then, we have a crucial toggle, Rubber Mode. This feature is all about speed and stealth. When enabled, Rubber Mode allows the tool to inject the payload before the main web interface is fully initialized on the device. This means your attack executes almost the moment the device is recognized, making it incredibly fast and much harder to detect. Finally, for those who want to fine-tune the core of the tool, we can dive into the main hamburger drop-down menu. Inside, you'll find the Settings page. This is where we can easily modify the critical configuration or _config file for the Atom Ducky. This gives you deep control over how the device operates, from network settings to advanced timings, allowing you to customize the toolkit to your exact specifications. Demo 1. Let's break something. I have a locked Android phone here. In just a few seconds, I'm going to plug this device in, and it will unlock the phone, open a specific WhatsApp chat, and send a pre-written message. No touching the screen after it's plugged in. Let's just see it happen. And just like that, it's done. The entire process from plug to send was under 5 seconds. Now, for those of you who are wondering how that was possible, let's break it down. For the tech enthusiasts in the room, I'll put the payload up on the screen now. So what you just saw was a sequence of 3 simple steps executed by this script. First, the wake and unlock. The ducky waits a second, types the PIN, in this case, 13,571, and hits enter. That's step 1. Next, it opens the browser and uses a direct WhatsApp link. The command GUI-B and then Control-L instantly jumps to the address bar, and it types https://wa.me/ followed by the target number. Android is smart enough to see that link and automatically hand it off to the WhatsApp app, opening the chat directly. No need to search or navigate manually. Finally, it sends the message. After a short delay for the chat to load, it types the message, "Subscribe to Crazy Panda." Then, it uses the tab key twice to navigate from the text box to the send button and hits enter. Message sent. This is a perfect example of why physical security is so important. If an attacker has a few seconds alone with your device and knows your PIN, the game is over. This could be a harmless prank, or it could be used to send a malicious link to someone from your trusted number. Demo 2. Alright, the main event. We're gonna witness a head-to-head battle.
Ladies and gentlemen, lock your firewalls, hide your Wi-Fi passwords, and for the love of bandwidth, please, update your antivirus. Because tonight, we're not just stealing data, we're stealing the spotlight. In one corner, the Noob hacker, powered by ambition, fueled by energy drinks, and armed with Google searches like how to hack in 5 minutes. His strategy? Hope and copy-paste. And in the other corner, A digital phantom, a glitch in the matrix, the FBI's recurring nightmare. The one, the only, crazy Panda. He doesn't just hack, he makes your router cry for mercy. 2 hackers, 1 device, infinite chaos. Who will control the system? And who will vanish faster than free trial software?
Buckle up, baby. Are you kidding me?
Alright, so our noob hacker has his device. It looks like a simple USB flash drive, but it's actually an Atom Ducky, a programmable keystroke injection tool. He's managed to get physical access to a target computer. He plugs it in. Now he pulls out his phone, which is connected wirelessly to the Ducky. He feels like a movie hacker. He finds the button to inject the payload, and he taps it. And boom, the payload runs. You can see it happen right on the screen. A PowerShell window pops open, and a malicious script starts to type itself out. It looks like it's working. He's in. But wait, what's this? Boom, gone. Just like that. The script is terminated, and the malicious file is quarantined. Our noob hacker is staring at the screen, confused. He forgot one of the most basic security features, Windows Defender Antivirus. His entire attack failed because he didn't account for the system's built-in protection. This is why they're called noob hackers. They have the tool, but they don't have the knowledge to make it work in the real world. Now let's see how a professional handles this. This is Crazy Panda. He's an elite hacker. He knows that modern systems are protected by things like UAC, User Account Control, and Windows Defender. He doesn't try to barrel through them, he systematically dismantles them first. He plugs in his Ducky. But this time, the payload is different. It's a masterpiece of precision and planning. And watch this. Start menu opens, UAC is typed. The slider moves to Never Notify. Start menu opens, Virus Protection is typed. The toggle for real-time protection is clicked off. Finally, a PowerShell window opens. A single silent command is executed, and it vanishes. And just like that, the lights are out. The defenses are gone. Back on his machine, Crazy Panda now has full, undetected control. He can steal files, install ransomware, or watch the user's every move. The attack is complete, silent, and invisible.
Wake up to reality.
So there you have it. The difference between a noob and an elite isn't just the tools they use, but the thought process behind the attack. One rushes in and fails. The other analyzes the battlefield, systematically removes every obstacle, and achieves the objective flawlessly. This is a powerful reminder that in cybersecurity, the human element is often the most critical factor. What did you think of this breakdown? Have you ever used a rubber ducky or similar device? Let me know in the comments below. If you learned something, hit that like button and subscribe for more deep dives into the world of hacking and security. Thanks for watching, and stay safe out there.